Oh, I am only going to go through the calculator section in detail because that's the section that I marked. If you've got questions about the non-calculator section, I do have my own solutions here and I can show you the solutions and talk about them, but I'll do that as a Q&A at the end. Whereas for the calculator section, I've got comments about what I noticed over the two classes and where people started to go a little bit wrong. Just a reminder, if you don't have your test today, but you want to sort of follow on with your own test, it is on Sector. So you can fire up Sector and open up your test, and there it is for you. Oakley dokley, here we go. This is the calculator section, and I feel like as if people still aren't there yet with their calculators. I think in general it would be fair to say that people did not utilize their calculator as best they could. I am going to fire. Let's get this happening in the background. Actually, I'm going to fire up the graphics display calculator and sort of show you how you can do things as you go along for the more the less straightforward problems. So here we go. Question 1. Pretty straightforward, guys. You're substituting in these values in for A and capital A, little a, and B, and away you go. What I found quite interesting is, and you're not alone if this was you, there were a heap of people who substituted 21.6 in for little a. Now, one might say, don't be annoying, Richard. Don't use the same letter for here and here, and then I won't get confused. But this should not be confusing you at this level. Okay, big A is different from little a. Okay, they are different things. This is the usual form of the formula. That's why I wasn't trying to trick you. This is just the usual form of the formula. The A and the B are the two parallel sides lengths multiplied by the height between those two side lengths. Halve it, and you get the area of the trapezium. And A is normally used for area, right? So I wasn't trying to trick you. I didn't mean it to be confusing, but honestly, at this stage, you need to understand that the case of the letter, uppercase or lowercase, does make it a different variable. Big X is different from little x. Big R is different from little r if you're doing two concentric circles, that kind of thing. Don't stuff that kind of thing up. That's a literacy problem, not a numeracy problem if you're doing that. Okay, question 2. This was my solution. It is not the only solution. One person in this room, I think from memory, converted everything to cents first, and I don't mind that approach. So they had 3s plus 5j equals 110 and 5s plus 3j equals 130, and then they solved from there. And then they were just working with whole numbers all the way through, and that is fine. Most people did okay, but not everyone. This was the bit that should have been the hardest bit of the whole problem, actually coming up with the model itself. And like lots of people did really well on that. They modeled it really well. But then they didn't follow through with a decent solution, and often because they didn't try using their graphics display calculator. Note as well that I took off half a mark, and I don't do this everywhere because otherwise it gets too punitive, but I took off half a mark if you didn't have your final answer with units. So either like that or like that is fine. But saying S equals 20 and J equals 10 and leaving it there with a full stop would have cost you half a mark. Okay, so if I was doing this on my GDC, I would just be going to menu, algebra. Oh, man. Menu, algebra, and I'd be going down to solve system of equations and solve system of linear equations. Two variables, S and J. You can leave it as X and Y, but then you have to translate it in your head. Now you type it in. So we've got 3S plus 5J equals 1.1. And then I can use my arrow key to go down to the next one, and it's 5S plus 3J equals 1.3. Do that, press the return key. There's my answers. 1/5 of a dollar and 1/10 of a dollar. You might be able to work that out to be 20 cents and 10 cents, but Control Enter will give it to me as decimals, 0.2 and 0.2 and 1.1, 20 cents and 10 cents. There you go. So it doesn't take too long to do. But of course, if you don't know how to use your graphics display calculator well, it's not like this for you, then of course it's going to slow you down. All right, before I move on to the next page, any questions? Speak now, forever hold your peace. This was done. Look, it wasn't too bad. Either you got the swing of it by now, or you didn't. Some people expanded it all. That's okay, but it's time consuming. The best thing to do is treat it like a difference of two squares and go a minus b. So x minus 1 minus x plus 1, x minus 1 plus x plus 1. And again, just putting brackets around it so you don't get confused with that minus going to each of the different parts there. So x minus x is 0, minus 1 is minus 2. I think I should have had a negative there. So I've got a negative there. I just didn't update my solution. So it's negative 4x. Oh, sorry, similar here. X plus x is 2x. Minus 1 plus 1 is 0. So it's 2x here. Negative 2 times 2x is negative 4x. That's all you had to do. Again, though, for a mark, just for a mark, menu, algebra, factor, or type it in. Literally as it says there, enter minus 4x. It's there for you on your calculator. If you didn't know how to approach it, then you could have done that. You could have also used, no, I won't go to that. I'll go through it a different time. This one here, I guess the thing to remind you of is that when you've got different terms, even if they're complicated like an x plus 1 cubed, when you've got different parts separated by a plus or a minus, you should look across each bit between the plus or the minus and see if there's a common factor. It's always the first step in a factorization. Is there a common factor? In this case, there is. It's 2. So if I take 2 outside, I'm left with just this bit here, x plus 1 all cubed, and I'm left with 64. Now, if you can't see 64 as a cube number, I get that it makes it difficult, right? You need to know your cubes a little bit. Like you need to know that 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125, okay? Just know those ones, it makes it easier. But when you see a cube here and you see a 64 here, once you've taken the 2 out, of course, you could go to your calculator and go cube root of 64. Oh, it's 4, and you're good to go, right? So you can confirm. What you need to be good at is seeing the pattern and going, oh, there's a cube here. I wonder if this is a cube. Some people were looking for a cube here, and they went, well, 128 is not a cube, therefore I can't use that method. But that's because you hadn't taken out a common factor first. So take out a common factor first, always, if it exists. What was quite common was people trying to expand it. And again, you weren't alone if you said this, x plus 1 all cubed is equal to x cubed plus 1 cubed. Ouchies. You need to be past that. We did Pascal's triangle expansions. You know that there's that this is a Pascal's triangle expansion. You need to be careful. The Pascal's triangle expansion, I think, is on your information sheet. You can always go there to have a look. So yeah, you make life difficult for yourself if you don't know the basics, and you make life difficult for yourself if you're not using your calculator. Again, I could have put that in. I could have gone factor. I don't know how good this will give it to me. Actually, 2 outside of x plus 1 cubed plus 128. Hopefully it'll give me the right thing. Doesn't always. It did. 2 times x plus 5 times x squared minus 2x plus 13. That is the correct answer. That would have given you 1 out of 2 marks just for using your calculator. 1 out of 2. Think about how many marks you were away if you didn't get this right, and see what happens if you added some extra ones in there from just using your calculator. Question 4 was a gotcha question. Gotcha. if I put this into my calculator, I think 5x squared minus 16x plus 12. Oh, I did do it. I had some students, and maybe it was the method they used, I'm not sure, who came out with 5 outside of x minus 2 outside of x minus 1.2. And it felt like a calculator factorization. I'm not too sure why my calculator didn't do that and yours did. Maybe it's the way you did it if that's you. But that's an example of where I can see it looks like you've used your calculator in order to solve the problem. But in fact, when we talk about factorizing, 9 times out of 10, we are looking for a factorization which is all whole numbers. Okay, all whole numbers. So you can see that the marks here were given for you using some method, the diamond method, or this new method that I worked out this year, which is a kind of a box method kind of thing, in order to factorize it out. That was really your only way of doing it effectively. And that's the end of that page. Any questions on that page? This is for you guys. I already know this stuff. Okay. I see some people I can see out of the corner of my eyes, some people are writing stuff down. That's really good. Next one. Use the quadratic formula to solve the equation, blah, 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 blah. I was really heartened to see, I think everybody, if not nearly everybody, rewrote it in this format first. Or if they didn't, they went straight to saying C must be minus 2 because you have to subtract 2 from both sides. That was really good, really well done. Not obvious necessarily. A lot of people would just go A, B, C. So the fact that you got the right ones there is credit to you. Because the quadratic formula and null factor law all work on an expression equaling 0. So if you didn't have equals 0, that would be a problem. Okay, as you can see, you get 1 mark for basically identifying A, B, and C by rewriting it. If you didn't do this here, but you I could see that you've done it, that's fine as well. Another mark for substituting into the quadratic formula, and then a half a mark for each of the correct solutions. Not everyone got the solutions correct. And the reason why they didn't get it correct is because they didn't do this bit here. Give your answer to 2 decimal places. Okay, so they just worked it out on their calculator and then just went from there. Honestly, though, in terms of the exam, it's so easy to make numerical mistakes in here where you've just accidentally stuffed it up. In terms of an exam or a test, this shows me that you know how to use the quadratic formula if you had to. Personally, I would be using the solve function in my calculator. Again, menu, algebra, solve. And then I would be putting in x squared plus 5x minus 2 equals 0, comma x. You always got to put the comma in. And it will give you this, which is the exact answer, but it's not the answer I was asked for. So control enter, and there are my 2 numbers. Said 2 decimal places, so minus 5.37 or 0.37, and then you're done. Okay? So you do this to show you know how to use it, but then you use your calculator to basically fast forward to the answer without having to worry about putting that whole thing in. And this I tried. If you had done this, people still weren't getting this right. I was really heartened by those who got it right straight away. The ones who didn't get right, the reason why I was worried is because it's been on a test or an exam for, well, you haven't seen exams, I suppose, but it's been on a test for like a bunch of years now. And it means that you maybe didn't cover it in the test, or you looked at it when you were doing your revision and went, I don't know, and moved on to the next thing. I even tried to give you more of a hint than I had in previous years by saying the factors will have square roots. The reason why this works is because it fits the pattern of a perfect square. We've got a square number here. Although this is not a normal square number 5, we can make it a square number by taking the square root of it. So the square root of 5 squared is 5. So I've got x and root 5, x and root 5, and twice. And the rest of it is you being able to see the pattern. That's a squared plus 2ab plus b squared. That's a plus b all squared. So that's how you can do it really quickly without a calculator. But again, if I use factor and I go x squared plus 5 multiplied, it wasn't 5, 2 multiplied by the square root of x, the square root of 5 multiplied by x plus 5, press return, it'll give me x plus root 5 all squared. So that's 1 mark you can get without even understanding how it fits the perfect square thing, but just by understanding how to use your calculator. Hence solve. Technically, when you see the word hence, it means use the result from above. So you set that, we can see that's the same as that. So we set the factored form equal to 0 and then null factor it to the final answer. Done. Anyone got any questions on that page? Okay, cool. I hope this is useful for you. This one here, students really did find challenging. I'm not going to lie, it's a challenging question. I have to put some challenging questions in there to ensure that I can get to, there are A standard sort of stuff out there. This required a little bit of thinking to get it working right. There is more than one way of doing this, but I believe this is pretty much the most straightforward way. If I take the -1 and add it to both sides, I get 4 times x minus 1 plus 1. There it is there. So now I'll have y equals 4 outside of x minus 1 plus 1 on this side. I've got y equals 2x minus 1 squared plus 1. And so now I can set them equal to each other. So that's effectively just a straightforward substitution method. So set them equal to each other. And you can see what I've done here. I've expanded, collected like terms on each side, collected like terms onto one side, and then this is really useful to do only when it equals 0. You can't do it otherwise. 2, even number, even number, even number. So I can I can divide everything through by 2. That gets me this, which I can then factorize, and then I can solve. Again, really complicated. 4 marks that was worth. You could have gained at least 1. You could have gained 1 mark just by doing this, and then maybe the rest of it was too complicated, you're running out of time. Then you get another mark just by telling me that the answers are 3 and 1. So I could have gone into here, and I could have gone menu, algebra, solve system of equations. They're not linear anymore, so I'll go solve system of equations. 2 equations with x and y in them. And then I could have gone, y is equal to 2 outside of x minus 1 all squared plus 1, just exactly as it's written in the problem. Oops. Down we go. Y minus 1 is equal to 4 outside of x minus 1. Return. X equals 1, y equals 1, x equals 3, y equals 9. I didn't actually, this is my fault. I didn't mean to make it more complicated. I forgot to say not to find the values of y in there. So sorry about that. But you can see it gives it to you straight away. X equals 1, y equals 1, so 1, 1. X equals 3, y equals 9, so that's 3, 9. And you'd be done. What I did in the end is I made it worth a mark here, and you basically got 1 mark for the coordinate 3, 9, and 1 mark for the coordinate 1, 1. So you could have picked up 2 marks just by being able to write it down from your graphics display calculator. I suspect that for a number of people, the start and end of their journey is like this. Here is a problem. I don't know how to solve it. Next question. But in the calculator section, just pause for a moment. I don't know how to solve it. Graphics display calculator, what can that do? System of equations, I can use that. Or use the factor button, or use the solve. So at least if you can't work it out yourself, that's understandable. But think about it. What how can I use that tool that I've got in order to use it? But of course, if you don't know what your graphics display calculator can do because you haven't practiced with it, then that's going to throw you out as well. And that would have given you 2, maybe even 3 if you'd done at least this line here out of 4 just by using your graphics display calculator. Question 7, it's not really a GDC question, and that's often in the calculator section. You'll find stuff that's GDC, graphics display calculator. This one didn't really require it. The number of people who saw this x minus 1 and then put p of minus 1 was quite significant. The number of people who used the factor theorem rather than the remainder theorem was quite big. It says the remainder is minus 1. So the remainder theorem says that if I substitute in this case 1, into the equation, the result will be minus 1. A number of people ignored this and just went, oh, it must be a factor, so I'll set it equal to 0. That tells me that you're using mathemagic instead of piecing it together. But the solution after that wasn't too difficult, so you can see it there for yourself. Any questions? Okay. Question 8. There was more than one solution to doing more than one way of doing question 8. Sorry, it looks a bit weird here because I rewrote the question when I thought it was a bit too hard to start with. So you've got this question here. The marks were given like so. You've got, for whatever approach you use to work out A, you got a mark for. For whatever approach you use to work out B, you got a mark for. For working out that A equals 2, that's a mark. For working out that B equals 8, that was worth another mark. So I'll just show you an example of an approach that you could take. It's not necessarily the approach that I've got here. But what I did is I took the 2 factors, x plus 2 and x plus 4, and I expanded them, x squared plus 2x minus 8. So because these are the 3 factors and x plus b, I can then multiply these 2 things together, and they must equal, when expanded, this. Now, what you could do is you could actually do the full expansion like this. Okay, so you could do all of that if you wanted to, and it would get you there eventually. However, what I did is I simply went, well, b has to be a number, not a variable. This is the only place where there's a number with no variable. And so if I multiply this by this, I need to get this. So in other words, minus 8 times b must equal minus 64. Divide both sides by minus 8, and I get b is equal to 8. So it gives me my b value. This bit here was a bit more tricky to see. This one, there's probably actually better. I think some students did it better than me, actually. So this is not, I'm not the best person to look at for this. But what I can do is I can see that for the x squared terms, I feel like I've missed the a somewhere. No, I haven't. For the x squared terms, I'm going to get the x squared by multiplying x squared by x squared by b. That'll give me bx squared. And 2x by x will give me x squared. And that's the only way I can get an x squared term when expanding this. So rather than expanding the whole lot, I'm just expanding the bits that will give me the x squared. So that ends up being bx squared plus 2x squared equals 5ax. So that means that that we knew that b was 8. So that's 8x squared plus 2, which will give me 10x squared equals 5ax squared. So that means that 10 must equal 5a, so a equals 2. Okay, this is a standard, this question, because it's quite complicated. So I'm going through it, but you can see that it's, it's not that straightforward at all. So don't stress if, if you want to get an A, that's the kind of level you'll need to be working at. And this one here, let's see what I wrote here. I didn't have any notes down for this one, so I think people did okay if they were able to do it. You didn't need to do this bit here. That's just me confirming that the remainder is indeed 5. But basically, you're doing a straightforward division here. So using the reverse box method, I won't go through it now because it's getting on in time. So I've put the x minus 1 down here because I'm told that's what I need to do. I've worked my way through the box method and I got 5x squared plus 6x plus 6 on the top. And then I just confirmed, what would I have to do to minus 6 to get it to minus 1? The answer is add 5. And so the remainder is positive 5. And again, if you've got time in the test, you could actually substitute it in to P of 1 to work out that it is 5 as well. I don't normally use this, but a couple of students from the other class did. I don't think anyone from here did. Evidently, under menu and algebra, let's have a look if I can find it, because I don't normally use it. Quotient of polynomial, I reckon. So I haven't used it, so I'm not going to waste your time now. But quotient of a polynomial or polynomial division, something like that, would allow you to get that answer straight up as well. So as you can see, using your calculator is really critical to success in the calculator section. Even if some of the content areas you're a bit weak on, you can still pick up marks all over the place there. I'm going to pause the video